Sudheesh, Katkam. So talk to us about how you can simplify and accelerate the actions in Python with Dremio and Apache.
Hi everyone, I'm Sudheesh. I'm an engineer at Dremio. We are building an open source self-service data platform. That's what we said us. All right, let's get started. So data comes in all shapes, sizes, and formats, meaning you have complex data like JSON, which is very loosely based. You have various sizes, meaning you have petabyte scale data. Sometimes you just have megabytes. Formats, right? So you have, like I mentioned, JSON or CSV, right? So these are generated by entities like us or by sensors, right? And there could be a stream being captured in storage systems, right? So in your company, you'll probably have a variety of data storage systems. For example, you probably store your documents in MongoDB or your transactions in SQL Server, or you just want to store files, you probably store them in a file system, right? Maybe a distributed file system if you want to store lots of data like HDFS. Right? You could even store data in Elasticsearch, so it's easily indexable, right? So from there, you want to look at how data gets to your applications, right? Like your Python applications in Jupyter, or how it gets to your BI tools like Tableau, right? It seems data takes a very complex path, right? For example, it goes through a lot of wrangling or curation, right? It even has, it may go through a bunch of ETL cycles. So you say, hey, from this system, I have to move it to this system just so I can analyze it, right? So let's look at how such a flow would look like. So it's time for a demo, right? Say I'm analyzing the Yelp data set. Let me increase the font size, right? So Yelp had published a subset of their data set, which shows which is typical of what Yelp has, right? Businesses, reviews, and user data. And I'm not happy with the suggestions it has. I want to find restaurants in Las Vegas that are most reviewed, and I want to actually use a different metric. Like I want to use the reviews that were useful to other people who were looking at that review, right? So for example, Yelp could store their business information in Elasticsearch because you search for that, right? It could store the review data in something like MongoDB, because MongoDB provides a flexible schema, and you can have fields dropped once a while or some fields missing and all of that, right? You can add new fields, things like that. So how would you answer this question, right? So this is, I've set up a Jupyter notebook for simplicity. All right. So first, let's algorithmically it would work by saying, hey, let me first find the best restaurants among the best restaurants, right? So first I need to find the best restaurants in LA and Las Vegas, sorry. And then I need to do some analysis. I need to do some analysis to find what some useful reviews are, and then do a join across those two, and then find out what the best numbers come out to be. All right. So first, I write some. I import their Python module to interact with Elasticsearch. It's running on the certain host somewhere, and then I'm searching what Elasticsearch is a concept of indexes, which is basically a bunch of documents together, right? And then I'm looking at business data in that, right? And I'm interested in a certain set of fields in there, and I want to filter them by Las Vegas, right? And I'm saying that anything greater than any restaurant that has a review count greater than 100, let's just look at that, right? You could add other filters saying, hey, it has really high ratings, but for simplicity, let's just do this. And then I have to normalize it. I have to normalize it so I can fit it into a data frame in Pandas, right? All right, here's what a sample data looks like. It has a business ID, categories, a city name, review count, etc., right? And how many stars it has. All right, now that I found out what businesses there are in Las Vegas, I need to find out what reviews there are, right? What people have reviewed. For this, I'm using a Mongo module by MongoDB, and anything that other users found useful as a metric for that, right? So, and I'm doing it in batches. I'll explain that later, right? A sample of that looks like, hey, this user ID reviewed this business, and this is what they think, and actually quite a few users found it useful. All right. So now that I have these two data sets, I need to do a join across them to figure out which businesses were actually good enough for these reviewers, right? So so one of the key things is if you did this completely in memory, it actually breaks down. It doesn't even finish. Sometimes it just says it throws out of memory, blah blah blah, right? So I had to do it in batches, right? I'm going to load MongoDB data in batches. So I mean, this is basically not so decent code that basically iterates over MongoDB cursor, and it returns data in batches, right? And I picked 25, seemed reasonable. And what this also does is, since I set the batch size to 25 here, and I set the iteration size to 25, for every 25 records, it's actually going to make a request and continue the cursor, right? That's what this is doing. And now let's do the actual join, right? The join is between the business data, right? On that table we saw business ID. On this table we also saw business ID, and we're going to do an inner join, meaning just ignore. It's a type of join. All right. So now we found the results, meaning we need to match the business IDs in these reviews that are streaming in a way, and we're going to match that against the businesses that we have in memory in a way, right? So we are going to do a Pandas as a nice merge function that does the join for us, and then we're going to append the results we're just going to keep track of all the matching ones, right? And even this actually took a really long time, so I just took a very small number. So once I hit a certain limit for how large my results it gets, I just stop. I mean, this is mainly I actually let it run for a long time, but it was too slow, and we'll discuss why that was too slow. So something like this will show up, meaning you have this restaurant, for example, has for this evaluation of the how good it is, it has an average score of average rating of 5, right? So sorry, forgot to mention I'm getting the stars from the reviews which were found useful, right? So I need to do a sum on that. That's what this is doing. All right. So what are some things that I did here? So I wrote domain-specific code for Elasticsearch. I wrote domain-specific code for Mongo, and there's a few things here that are actually happening, right? Turns out here, right? So join this, for example, when I'm trying to get transform the results from what the join returned to something that I want to keep in memory. This is actually creating 2 copies. Turns out internally, and every time you append, it also does 1 more copy. So, but there's no reason to actually copy the data, right? You can just what the fields are. You have it in memory. Why make another copy, right? And every time I actually have to go over the cursor, right? What I'm creating is something like this, right? I need to turn that result set that I'm getting from Mongo into a list, and then I need to turn it into a data frame. Now that's again 2 more copies, right? So an ideal scenario would be that once the data is read from a source system, it's in a format that helps analytics, right? In the sense that you don't have to once it's transferred from one system to another, you actually don't need to create a copy, right? And that's what I'm going to talk about next. So let's first talk about how the layout is. So you can imagine a table with 3 columns that way, and if you had laid it out in memory, in RAM, for example, typically you would see them record after record, right? So you will see the first field of the first row and the second field of the first row, and so on. You would see that in order. The problem with this is the type of workload that analytics have. They pick a few columns and they work on that, right? They don't work on the entire record per se. right? Say you're filtering on a certain column and you're summing on another column, right? You only need those two columns, right? So something like this would be a little more useful because you will avoid cache misses, right? You will have, say, for example, you're picking the session ID column, right? Once you hit the first one, say let's just look at it as an integer, and you want to do a sum over it, right? Well, if you hit the first one and the next one is right there, right? You don't have to reload another record into memory for that. So let's base it off on that. And there's an open source project called Apache Arrow that works to enable columnar analytics. And what the goals of Arrow are simple. So it enables columnar in-memory analytics specifically, meaning once you have data loaded into a process's memory, you do not have you need to since we're going to represent into columnar format. That's very friendly to analytical applications. And zero copy messaging. What that means is, say you have two processes running on the same node, right? So they don't actually have, if both represent the underlying data in the same format, they don't actually have to send from one system to another. When you're sending, you're going to serialize it. When you're receiving, you're going to deserialize it. And then you're going to convert it into the system's internal representation, right? So all of those steps that can be skipped, for example, by using a memory map file, right? You can just say, hey, look at this file, and this process is also going to look at the same file, since both of them had initially agreed that this is the memory layout they're going to deal with. Then they don't have to do any copies, right? And you can also have inter-process communication, meaning across a network, right? Meaning a process on one node is trying to talk to a process on another node. What you would do is negotiate a schema for the memory layout that you're going to have, and then you're going to send it over. You're going to send that what the layout looks like, and then you're going to send the data along. And the other system, once it reads it off the socket, doesn't actually need to create another copy, right? Because they already know what the layout looks like. So this obviously requires things to work across languages, and so we have multiple implementations in C++, Java, and there are bindings in other languages too. And definitely, like data is complex, and so there needs to be support for nested schema. So it's based off on the JSON model. So we support nullabilities, there's support for arrays, there's support for objects, right? So that's the goals of Arrow. And so what system communication across all the services you have in your company would be, instead of copying and converting between any two systems, it would just be, hey, we all speak the same language internally and externally, so we can just agree on how the data looks. So another key thing for this is adoption. You need a lot of projects to expose such an API, so there's not a lot of copies, right? So how does this actually help? Let's go back to the code, right? Looking at the current way, so that means if you had that, right, this call, right, would not be, if the batch cursor API in Mongo, for example, was speaking Arrow, then this call would basically not incur any cost, right? You're not copying any data. You're just looking at the data through this frame, right? And then this cost, right, the cost of this, maybe you can maintain a memory layout that just is pointers to the records in one data frame and another data frame, right? And so here too, right, when you're not creating any copies, you're actually just saying, hey, I'm only interested in these two fields, so it's like a projection. I ignore the other fields that are in the data frame, and I just look at these two. All right, let's go back. So we have up to now we have so we have a common language to speak, but we don't have something that interacts with multiple systems, right? So the initial thing that we had was something that was, the program was interacting with MongoDB and Elasticsearch, and it was coming up with some answers. So how do you do that is what Dremio tries to solve, right? We are a self-service data platform, and we are open source. Self-service data platform, I'll get into the details when I'm doing the demo. And we are also built on other open source technologies like Calcite. We use Calcite extensively in planning. We use Arrow extensively in our execution engine. And I have a lot of stickers. Our thingy is a narwhal, and you can get some of those. I have Arrow stickers as well. All right. Now imagine what the problem we're trying to solve in a picture is this. Right? You have a bunch of data sources, and you have a bunch of applications, and you want to provide a unified access layer to those applications as if these systems are just one. Right. So that's what we try to do. And one of the key things to that is search. Right. You want to be able to search the data sources, data sets that you have in your company. You want to be able to curate them, meaning you want to drop some fields or you want to massage the data somehow. That's what curation helps you, right? At the end of this, if you're not happy, we have an intelligent cache layer, which is how we accelerate data, right? And the thing about virtualization is, in the original description that I had was basically when you have data movement from one system to another. It's typically to help make it a more, I guess, it helps the applications understand the data more, right? So you're making raw data, you're cleaning it up, and then you're making it in a form that's more digestible by applications. But you don't really need to do that. What you're doing is actually wearing on a lens, right? You're saying, hey, I'm looking at the raw data, but then let me wear on this lens and say, hey, this field is actually a timestamp, even though it looks like a string, right? You're just interpreting it as a timestamp, right? So you have this view of data that's not really changing the original data itself, right? What that helps with is you don't have to make copies of the data, right? So you're not going to move from one system to another. You're just going to say, let me interpret the data this way. That's what virtualization is, and we provide that across different data sources. All right. Let me show you how a similar thing would work with Dremio. So we support, let me just make sure things are all right. So you have for example, Elastic. We support HBase, HDFS for people who know what that is. And we have Mongo dataset. So for example, Elastic has a concept of index, right? So Yelp is an index. This is a simple browser interface that we have. And Yelp is an index, and these are the datasets that I have in the Yelp index, right? These are the types. That's what Elasticsearch calls. In Mongo, I have the same database called Yelp, and I have different collections, right? And each collection is basically a bunch of documents, right? Let's, for example, look at user collection, right? Supposedly users can be funny too. I thought only reviews can be funny. All right, so this one, right? This one shows a tabular representation of that. All right, let's get to what we're trying to solve. First, we were looking at Elastic dataset, right? We were saying, let's go to the business data. And let me go back to the algorithm again, just to make sure I got it right. All right, so first I'm filtering based on the city. So I have a city, let me pick, I'm only interested in Las Vegas. So let me apply that, right? Let me apply that filter. So what you're actually seeing is a sample of the data for now, because it's a large data set. We don't show you the entire data set at once. But when you run it, so this is a preview of the data set, but when you run it, you can hit run. We'll do that a little later. All right, so we went to the Las Vegas restaurants, and then we have review count greater than 100. Where's the review count? The format sometimes changes, so I have to be, oh, right here, sorry. All right, I'm gonna keep only the ones that are greater than, I think, 100. So I can just say 100. So now I'm looking at, I'm not actually modifying, I'm not transferring any data from MongoDB into Dremio. I'm just saying, hey, let's only look at this data set, this view on the data set. All right, I'm not actually interested in any other attributes. Let me just drop a few. I know all the state is always going to be Nevada. Right, I'm interested in the name. Okay. Underneath, it's actually just a SQL statement because we're just going to say where city is Las Vegas and the review count is so and so. All right, I'm going to save this as I don't know, Las Vegas restaurants. So now what I actually created is called a virtual data set, right? So we had the physical data set and we have a view of that data set, and that's captured here, right? All right, and then what did I do? I did a join, and then I imported the, MongoDB data based on the useful count, greater than being 5, right? So let's go there now. Now I have Mongo data, Yelp, reviews. All right, notice that useful is actually part of a nested field, right? It's a JSON blob. So that's what this tiny little thing is showing, that it's complex. So I'm looking at useful, right? I can extract that field, right? And I'm interested in useful words now. Apply, right? And I want the useful words to be greater than 5. So I can again keep only the ones that are greater than 5. I'm actually not interested in the entire text, so I'll just drop this. This is probably the largest one. All right. Let's save this one as this one called reviews. Let's call it my reviews. Okay, so we have two virtual data sets, right? And we can now apply the same join algorithm, right? Which is to say, let's look at restaurants and let's do a group by, right? Sorry, it's not a group by. Cancel. I'm doing a join, right? So notice how it actually suggests some other data sets that are available as potential join data sets. But it's a custom join because I'm only interested in my reviews, right? So here, then I have to pick what's the key that I'm joining on. Business ID on this side, and on this side I have business ID as well. Right, and then just keeping the other columns. All right, let's go back again. We see that now we did a join, and then we have to only pick the source name and stars, right? And we have source name, which I think is called name, and stars. This stars actually is the stars on the review, sorry, on the business side, and this one is the one that user had. So I'll just call it user stars. So again, now this I can save again as a join data set, right? So, all right. So join data set, I can drop most of the fields, right? If I want, I can edit the original SQL. I don't have to look at I don't have to always do it visually. If I understand SQL, then I might as well do SQL. All right, so there's user stars and user stars. So we have a search in there. All right, I need to keep user stars and business name. Oh, I think it's just called name. that, and let's paste it here. All right, I'm just dropping the other columns. I'm not interested. All right. All right. So we did the same same algorithm through this, except I don't think I had a group by, right? Meaning I need to collapse all the ones that were for a specific restaurant. So let's do a group by on the name. Okay, and measure, I'm going to do a sum on the user stars field. And average. Just to keep it similar to what the original one looked. All right. I can hit preview, and I will see similar results. Right. So, join data sets. If I go back now to where I created these are the data set I created. I created a similar flow. And now, how do I get it back to Pandas, right? So now that I visually curated the data and created this the same algorithm through just drags and drops and SQL, that's what it looks like. So through this, we need PyODBC, which is a ODBC connect, which is a module that helps you use the ODBC API to connect to databases, and Dremio has a ODBC API, right? So we are connecting through an open source driver, and actually this is wrong, so I need to fix that too. From I think Sudheesh dot join dataset. All right. So I set up my initialization file in the home directory to point to that cluster and to the setup with my credentials. That's required for any ODBC application typically. All right, so running this, oops, what did I miss? Driver did not supply an error. All right, very useful. Okay, I'm guessing it's with the syntax. No? Okay, so let's see, maybe the job failed. We'll find out what happened to the job. Ooh, failure parsing query. Although, we can find out what failed. Details, maybe? Alright, let's look at what the error message is. Oh, it doesn't like quotes. That's what it is. Right, this driver doesn't always give us nice error messages. Now it's running. So there, we got the results. So maybe we got different numbers, but that's because the other one I restricted it to a certain data set size, right? Okay. So few things that this algorithm did that were nice was the fact that we already filtered the results from MongoDB, and we already filtered the results from Elasticsearch before loading it to our system. What that means is we have, instead of loading the entire data set into Pandas, which is ridiculous, on Elasticsearch and Mongo, instead of doing that, we said, hey, do this part of the filtering in your system and then return the results, right? So that's very important, and we actually do that too. That avoids data movement, right? Unnecessary data movement. That's what we do too. In Dremio, so when we ran this query, it actually did not scan the entire tables from Elasticsearch or MongoDB into Dremio and then do the join. What it did is, again, it's smart enough to figure out that parts of the query, right? Where's the, okay, I think it's defined in the other data sets, right? For example, in this one, it says, hey, this where condition can actually be pushed to MongoDB, and that's very important because that will reduce the data set size that's coming into Dremio. But similarly, that's true for Elasticsearch as well. When we looked at this, these two are conditions that can be pushed to Elasticsearch, right? So we don't have to scan the data or move it across systems. All right. Another cool feature that we have is when you're looking at the joint data sets, you can also see where the data came from. We know that originally the data was in Elasticsearch and MongoDB, and then we had this view of the data. And then on Elasticsearch, we had a view of the data on MongoDB, and then we did a join in our system. All right. How am I doing on time? Let me just check. Yeah, 53. So yeah, that's Dremio. We are a tier that lives between applications and your data sources, and this allows you to access any scale data or any type of data from your Python application. All right, and it's an open source, as I mentioned, it's an open source project. You're welcome to contribute. Arrow is also an open source project. You can see a lot more tutorials on how the internals of Dremio are, and there's a lot of tutorials on how to use it through Pandas or Tableau, for example, on our website. And yeah, questions? Yeah.
So when connecting Python to Dremio, you're forced to use doesn't Dremio already have Arrow gateway? You can just send the Arrow gateway and not have to do extra conversions to get it back.
Good question. You caught me there. I forgot to mention there's one part that's missing there. We are using an ODBC API, which is a standard API which does not support Arrow, right? As an API. So we are working on that. So we are working on providing another API. So actually, what happens is it comes all the way to the client in those Arrow batches, but at the end it gets translated to an ODBC API and then into a data frame. So instead of that, you could just collapse those conversions and copies, and you could just provide an Arrow API, right? That's very important again, right? Because you can avoid the copy there. And right, as of now, we are expecting the dataset sizes to be small. That should be fine because it's only when you're moving large amounts of data that Arrow really helps. Come on. Yeah. Right. So in this case, we are always. So what I showed was that the data was directly coming from the sources. Right. There was no copy maintained in Dremio, right, of any form. What you could do is, if there are some popular data sets, virtual or physical, you can accelerate it. Meaning, you can say, hey, cache this data in your system. We allow for that. And how we allow updates in that is it's almost transparent to the user. You define a policy on how fresh the data should be. Right? You say maybe 3 minutes or 3 hours is how much I'm willing to give a leeway for. So we do have. You can set those policies on accelerations. That's right. Across on the same on different nodes. That's right. For if it's on different nodes, then you do have to send it over the wire. But then you only send, and there's no serialization or deserialization costs, or there's no copying it into a format that process understands if you're using something like Arrow. Mm-hmm. That's correct. So unless you're using shared memory, that's right. You're not. But in this case, there's no reason not to use shared memory if you're gonna actually share with another process a format that the other process already understands. That is correct.
More questions? So let's